Section 422.16 addresses appliance cords, stating that they are generally allowed to connect appliances to a receptacle outlet. However, it's important to note that dropped appliances are not permitted to be connected with appliance cords. Section 422.17 focuses on cord and plug connected appliances, specifically those that are fixed in place. According to this section, fixed in place appliances should typically be connected using permanent wiring methods. There are, however, exceptions to this rule. Exception number 1 states that appliances that are cord and plug connected are permitted to be arranged so that they can be taken apart at the point of connection between the appliance and the flexible cord. This arrangement allows the appliance to be easily moved for maintenance or repair, provided that the appliance is not intended to be moved as a whole. Exception number 2 provides an allowance for listed appliances that are rated at less than 125 volts, 15 amps, and have flexible cords that are no longer than 6 feet and without terminals for attachment to receptacle outlets. These appliances are permitted to be connected to a receptacle outlet. Based on these code sections, a drop-in hot well in a restaurant that is intended to be fixed in place should be hardwired, not connected using an SO cord. However, if the hot well is specifically designed to be easily moved for maintenance or repair, and it is not intended to be moved as a whole, then it may be connected using an SO cord, as allowed by exception number 1. It is always best to consult with a qualified electrician to ensure the proper installation and connection of any electrical equipment. Now let's delve into some related concepts, such as the different types of wiring methods, the proper selection of flexible cords, and the importance of equipment listing and labeling. Permanent wiring methods can include the use of conduit, such as electrical metallic tubing or rigid metal conduit, as well as cable wiring systems like non-metallic sheath cable or armored cable. The choice of wiring method will depend on factors such as the environment, the voltage and current requirements of the appliance, and any local code requirements. When selecting a flexible cord, it's essential to consider the type of environment in which it will be used, the amperage rating of the appliance, and any applicable listing requirements. For example, an SO cord, which stands for Service Oil Resistant Cord, is designed for use in damp or oily locations. Other types of flexible cords include SJ cords, which are Service Junior cords, and SV cords, which are Vacuum Cleaner cords. Each type of cord has different properties and is suitable for different applications. It's also crucial to ensure that any electrical equipment used in a commercial setting, such as a restaurant, is properly listed and labeled by a recognized testing laboratory. Listing and labeling indicate that the equipment has been tested and meets applicable safety standards. This provides assurance that the equipment is safe to use and that it is suitable for its intended purpose. Additionally, it's important to follow the manufacturer's instructions for installation and operation of any electrical equipment. The manufacturer's instructions will provide specific guidance on how to properly install and connect the equipment, as well as any safety precautions that should be observed. Failure to follow the manufacturer's instructions can result in damage to the equipment, electrical hazards, or even injury. Let's elaborate on the considerations for appliances that need to be moved for maintenance or repair. The key point here is that the appliance should be designed to be easily disconnected and moved without requiring extensive disassembly or the use of specialized tools. The cord and plug connection should be readily accessible, and the cord should be of sufficient length to allow the appliance to be moved to a convenient location for servicing. Furthermore, the cord should be protected from damage and strain, and it should be properly supported to prevent it from being pulled or stretched. If the appliance is located in a damp or wet location, the cord and plug connection should be suitable for use in such an environment, and any exposed metal parts should be properly grounded. In some cases, it may be necessary to install a ground fault circuit interrupter, or GFCI, to provide additional protection against electrical shock. A GFCI is a device that detects ground faults and interrupts the flow of electricity to prevent injury. GFCI protection is typically required in areas where there is a high risk of electric shock, such as kitchens and bathrooms. When dealing with electrical installations in commercial settings, it's always best to err on the side of caution and to consult with a qualified electrician. A qualified electrician will have the knowledge and experience necessary to ensure that the installation is safe, compliant with all applicable codes and regulations, and suitable for the intended use. They can also provide guidance on the selection of appropriate equipment and materials, as well as any necessary safety precautions. In summary, the decision to use an SO code or hard wiring for a drop-in hot well in a restaurant depends on several factors, including whether the appliance is intended to be fixed in place or easily moved for maintenance or repair, the voltage and amperage rating of the appliance, and any applicable code requirements. By carefully considering these factors and consulting with a qualified electrician, you can ensure that the installation is safe and compliant with all applicable regulations. Additionally, it is important to always refer to the latest edition of the National Electrical Code, or NEC, for the most up-to-date requirements and guidelines. The NEC is a comprehensive set of standards for electrical installations that is widely adopted throughout the United States. It is updated every 3 years to reflect changes in technology and best practices. Staying informed about the latest NEC requirements is essential for ensuring the safety and compliance of electrical installations. In addition to the NEC, there may be local codes and regulations that apply to electrical installations in your area. These local codes may be more stringent than the NEC, and it is important to be aware of them and to comply with them. Your local building department or electrical inspector can provide information on any applicable local codes and regulations. When planning an electrical installation, it's also important to consider the long-term needs of the facility. Will the appliance need to be upgraded or replaced in the future? Will additional electrical capacity be needed to support future growth? By planning ahead, you can avoid costly and disruptive modifications later on. For example, it may be wise to install a larger conduit or race width than is currently needed to accommodate future wiring changes. Or, you may want to consider installing the sub-pole to provide additional circuit capacity. In some cases, it may be necessary to perform a load calculation to determine the total electrical load of the facility. A load calculation is a process of estimating the amount of electrical power that will be consumed by all of the appliances and equipment in the facility. This information is used to determine the size of the service entrance and the capacity of the electrical distribution system. Load calculations are typically performed by a qualified electrician or electrical engineer. When working with electricity, safety should always be the top priority. Always de-energize circuits before working on them, and use appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work for you. Electricity can be dangerous, and it is not worth risking your safety to save a few dollars. Remember that proper grounding is essential for electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to protect against electrical shock. All electrical equipment should be properly grounded, and grounding connections should be regularly inspected to ensure that they are in good condition. Surge protection is another important consideration for electrical safety. Surges are brief spikes in voltage that can damage sensitive electronic equipment. Surge protection devices, or SPDS, can help to protect against surges by diverting the excess voltage to ground. SPDS are typically installed at the service entrance and at individual circuits. Regular maintenance is also important for electrical safety. Electrical equipment should be inspected regularly for signs of wear and tear, and any damaged or worn parts should be replaced promptly. Electrical panels should be kept clean and free of debris, and all connections should be tightened periodically. By following these simple maintenance tips, you can help to ensure the safety and reliability of your electrical system. Finally, it's important to remember that electricity is a powerful force, and it should be treated with respect. Always follow safe work practices, and never take shortcuts or compromise on safety. By doing so, you can help to prevent electrical accidents and injuries. So, to reiterate, when deciding whether to use an SO cord or hardwiring for a drop-in hot well, always consider the specific requirements of the appliance, the applicable code requirements, and the long-term needs of the facility. And when in doubt, consult with a qualified electrician to ensure that the installation is safe and compliant. In a specific context of a restaurant, there are additional considerations to keep in mind. Restaurants are typically high-traffic environments with demanding electrical loads. Electrical equipment in restaurants is often subjected to harsh conditions such as heat, moisture, and grease. Therefore, it is especially important to select electrical equipment that is suitable for use in these conditions. For example, wiring and cable should be rated for high temperatures and should be resistant to moisture and grease. Electrical enclosures should be NEM rated to protect against the ingress of water and other contaminants. In addition, restaurants are subject to strict health and safety regulations. Electrical installations must comply with these regulations to ensure the safety of employees and customers. For example, electrical equipment must be properly grounded to prevent electrical shock, and wiring must be protected from damage to prevent fire hazards. Restaurants also typically have a high demand for electricity. Lighting, cooking equipment, refrigeration, and air conditioning all consume significant amounts of power. Therefore, it is important to design an electrical system that can handle the load. This may involve installing a larger service entrance, using energy-efficient equipment, and implementing load management strategies. Energy efficiency is another important consideration for restaurants. Restaurants consume a significant amount of energy, and energy costs can be a major expense. By implementing energy-efficient strategies, restaurants can reduce their energy consumption and save money. Some energy-efficient strategies include using LED lighting, installing energy-efficient appliances, and optimizing the use of heating and cooling systems. In addition to the technical aspects of electrical installations, it is also important to consider the aesthetic aspects. Electrical equipment should be installed in a way that is visually appealing and does not detract from the overall design of the restaurant. Wiring should be concealed where possible, and electrical panels should be located in inconspicuous areas. The goal is to create an electrical system that is both functional and aesthetically pleasing. When planning an electrical installation in a restaurant, it is helpful to work with a qualified electrical contractor who has experience in this type of work. An experienced contractor will be familiar with the specific challenges and requirements of restaurant electrical systems, and they can provide valuable guidance and expertise. They can also help to ensure that the installation is safe, compliant with all applicable regulations, and suitable for the intended use. To further illustrate the importance of code compliance, consider the potential consequences of a non-compliant electrical installation. A non-compliant installation can create a fire hazard, increase the risk of electrical shock, and lead to equipment damage. It can also result in fines and penalties from local authorities, and it can invalidate insurance coverage. In the worst-case scenario, a non-compliant electrical installation can lead to serious injury or even death. Therefore, it is essential to ensure that all electrical installations are performed in accordance with applicable codes and regulations. Now, let's delve deeper into the types of flexible cords mentioned earlier, specifically SO, SJ, and SV cords. SO cords, as mentioned, are service oil-resistant cords designed for heavy-duty use in damp, oily, or harsh environments. The S indicates that it is a service cord rated for 600 volts, and the O signifies its oil resistance. These cords are typically used for connecting portable tools, equipment, and appliances in industrial and commercial settings. SJ cords, or service junior cords, are lighter-duty versions of SO cords rated for 300 volts. They are suitable for use in less demanding applications, such as connecting portable lamps, small appliances, and office equipment. While they offer some oil resistance, it is not as robust as that of SO cords. SV cords, or vacuum cleaner cords, are designed specifically for use with vacuum cleaners and other light-duty appliances. They are typically rated for 300 volts and have a thermoplastic or rubber insulation. SV cords are not oil-resistant and should not be used in damp or oily environments. When selecting a flexible cord, it is crucial to consider the specific requirements of the application, including the voltage, amperage, environmental conditions, and any applicable listing requirements. Using the wrong type of cord can create a safety hazard and lead to equipment damage. In addition to the types of flexible cords, it is also important to consider the gauge, or thickness, of the wire. The gauge of the wire determines its current carrying capacity. The higher the gauge number, the smaller the wire and the lower its current carrying capacity. It is essential to select a wire gauge that is appropriate for the amperage rating of the appliance or equipment being connected. Using a wire that is too small can cause it to overheat and create a fire hazard. The NEC provides tables that specify the allowable ampacities of different wire gauges based on the type of insulation and the ambient temperature. These tables should be consulted when selecting a wire gauge for a particular application. Let's also discuss the importance of proper overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. An overload occurs when a circuit is carrying more current than it is designed to handle. A short circuit occurs when there is an unintended connection between two conductors. Overcurrent protection devices interrupt the flow of electricity when an overload or short circuit occurs, preventing damage to the wiring and equipment and reducing the risk of fire. It is essential to select overcurrent protection devices that are properly sized for the circuit they are protecting. The size of the overcurrent protection device should be based on the ampacity of the wire and the rating of the equipment being protected. The NEC provides guidelines for selecting overcurrent protection devices. In addition to circuit breakers and fuses, there are other types of overcurrent protection devices, such as ground fault circuit interrupters, or GFCs, and arc fault circuit interrupters, or FCs. GFCs protect against ground faults, which occur when there is an unintended path for current to flow to ground. FCs protect against arc faults, which are dangerous electrical arcs that can cause fires. GFCs are typically required in areas where there is a high risk of electric shock, such as kitchens and bathrooms. FCs are typically required in bedrooms and other areas where there is a high risk of fire. To further emphasize the importance of electrical safety, consider the following statistics. According to the National Fire Protection Association, or NFPA, electrical failures or malfunctions are a leading cause of residential fires. These fires result in billions of dollars in property damage and hundreds of deaths each year. Many of these fires could be prevented by following basic electrical safety precautions, such as using properly sized wiring, avoiding overloading circuits, and having electrical systems inspected regularly. Electrical safety is not just a matter of following codes and regulations. It is a matter of protecting yourself, your family, and your property from the dangers of electricity. By taking the time to learn about electrical safety and by following safe work practices, you can help to prevent electrical accidents and injuries. So, as a final reminder, when working with electricity, always prioritize safety. To energize circuits before working on them, use appropriate personal protective equipment, and consult with a qualified electrician if you are not comfortable performing the work yourself. By doing so, you can help to ensure that electrical installations are safe, compliant, and reliable. And remember, the information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer for specific guidance on electrical installations.